Hi, I'm Jared Shanko. I'm here to talk about mathematical induction and its real-life application. Mathematical induction. Definitions. Mathematical induction is a method of mathematical proof typically used to establish that a given statement is true for all natural numbers. Inductive reasoning. The process of making inferences based upon observed patterns or simple repetition, often used in reference to predictions about what will happen or does happen, based upon what has happened. Proof by induction is done in two steps. The first step, known as the base case, is to prove the given statement for the first natural number. The second step, known as the inductive step, is to prove that the given statement for any one natural number implies the given statement for the next natural number. Hence, mathematical induction is the rule from which we infer that the given statement is established for all natural numbers. How can we apply this in real life? To understand how induction works, I will give you some examples that can happen or encounter in daily life. Example 1. Santa asks all children in the mall to line up holding a box of candy bar. The child at the beginning of the line gets a candy bar. If the first child gets a candy bar, then the following kid in line also gets a candy bar. Let's number the children by their order in the line, starting the count with 1. Now we can understand the second rule with the following sequence of the statements. If child 1 gets a candy bar, then child 2 also gets 1. If child 2 gets a candy bar, then child 3 also gets 1. If child 3 gets a candy bar, then child 4 also gets 1. We can actually represent this in a concise mathematical description. If a child n gets a candy bar, then child n plus 1 gets a candy bar for all non-negative integers n. So suppose there are 15 children in the line. By said rules, are all entitled to a candy bar? Well, child 1 gets 1, which means child 2 gets 1, child 3 gets 1 as well, and so on. By 15 applications of the second rule, all kids in the line get a candy bar. Hence, n is equal to 1 is the base case, or when n is equal to the lowest value, and the inductive steps shows that if the statement holds for some n, then the statement also holds when n plus 1 is substituted for n. Example 2. A math teacher announces to his class that there will be a quiz in one of the 5 days for the coming week. He also mentioned that it will be a surprise quiz and they won't be able to predict the night before that it will happen the next day. A smart student tells the class the quiz can't be given on Friday for sure because that's the last possible day, so we will be able to predict it Thursday night. So Friday is out. That makes Thursday the last possible day the quiz can be given. But then, the quiz also can't be given on Thursday because Wednesday night we would know it was coming the next day. And in the same way, we can eliminate Wednesday, Tuesday, and even Monday from the list of possible days for the quiz. Because of mathematical induction, this argument made the class happy because it means that there can be no surprise quiz. The teacher then say, "Since you figured it out, I will give a short quiz next Monday," and this is now announced. Example 3. The sinking Titanic. Mathematical induction can also be demonstrated in a real-life situation. The crew of the Titanic realized that the ship was doomed when they realized that the bulkhead that was being flooded would be completely flooded. Consequently, when a given bulkhead was completely flooded, the next bulkhead would undergo the same fate after the rest of the remaining bulkheads, thus sinking the whole ship. In conclusion, there are many applications of mathematical induction in our daily life. Hope you learned something and thank you for listening. This is Jared Shanko. Have a nice day.